Problems. Maclaurin's theorem. Expand y is equal to e power sin inverse x. Proof. Y is equal to e power sin inverse x. Call it by equation 1. So, at the point y of 0, e power a of sin inverse 0. That is equal to a power a into sin inverse 0 is 0. E power a into 0 is 0. E power 0 is 1. So, y1 e power a sin inverse x a times 1 over root of 1 minus x square. So y1 is equal to ay upon the root of 1 minus x square. At the point 0, that is a y0 root of 1 minus 0 square. That is a into 1. Y of 0 is 1. That is a. If you square, that is y1 square is equal to, cross multiply this to here, it will become 1 minus x square is equal to a square y square. Differentiate, that is y1 square minus 2x plus of 1 minus x square 2y1 y2, that is a square 2y y1. So, or you can rewrite this as 1 minus x square y2 minus xy1 minus a square y is equal to 0. If you differentiate n times, that is d power n 1 minus x square y2 minus it is d power n of xy1 minus a square d power n of y. So by Lybnard's theorem, it is 1 minus x square yn plus 2 plus n of minus 2x yn plus 1 plus n minus 1 minus 2 upon 2 factorial yn minus of 1 minus 1 into x yn plus 1 plus ny1 minus a square yn. If you differentiate it 10 times, it will become yn. So it is nothing but 1 minus x square yn plus 2 minus of 2n plus 1 x yn plus 1 minus of n square plus a square yn is equal to 0. You can rewrite this as 1 minus x square yn plus 2 is equal to, shifting to other side, it will become plus 2n plus 1 x yn plus 1 plus of a square plus n square of yn. That is at the point 0, if you do 2n plus 1 y of 0 plus a square y of 0, that is a square, you are left with y of 0 is 1, that is a square. So y3 of 0 1 plus a square y1 0, that is 1 plus a square y1 0 is 1, y1 0 you got here, that is a. So this is the answer. If you do this in terms, e power sin inverse x, that is y of 0 plus y1 0 plus x square by 2 factorial y2 of 0, that is 1 plus xa plus y1 0 is a plus x square by 2 factorial a square plus dot dot dot, that is e power sin inverse x is equal to x power n by n factorial yn of 0. Next problem, second problem, e power ax sin bx. Proof. Y is equal to e power ax sin bx. We know that is yn is equal to r power n sin of bx plus n phi, where r is nothing but root of b square plus a square. If you square the both side, it will become b square plus a square. So and phi is nothing but tan slope, that is tan inverse of b by a, that is y of 0 e power a into 0 sin b of 0, that is e power a into 0, that is 0 sin 0 is 0, that is e power 0 is 1 into 0 will become 0. So y1 is equal to r sin bx plus phi, that is y1 of 0 r sin b of 0 plus phi that is r sine phi. b0 you got as 0. So y2 you will get r square sine bx plus 2 phi, that is y2 of 0 r square sine 2 phi. So by Maclaurin's theorem, e power ax sin bx is equal to y of 0 plus xy1 of 0 up to x power n by n factorial, that is r power n sin n phi, that is 0 plus x of r sin phi plus x square by 2 factorial r square sin 2 phi up to x power n by n factorial r power n sin n phi. So you know tan phi is b by a slope. You can conclude from this figure, that is b a hypotenuse opposite adjacent, this is root of a square plus b square. You'll get sin phi as b upon root of a square plus b square, that is b by r, it is nothing but r. Cos phi is a upon root of a square plus b square, that is a by r. So you can substitute for this r square sin 2 phi, you can rewrite this as r square 2 sin phi cos phi, that is r square 2 of b by a by r. b by r it is into a by r, that is 2ab. r cube sin 3 phi, you can rewrite this as r cube 3 sin phi minus 4 sin cube phi, that is r cube 3 sin phi of sin square phi plus cos square phi minus 4 sin cube phi, that is r cube 3 sin phi cos square phi minus sin cube phi. Sin square phi plus cos square phi is 1. So you can read this as 3r sin phi r cos phi whole square, it is minus of r sin phi whole cube, that is 3 of ba square minus ba cube, that is b of 3a square minus b square. If you take out b as common, so e power ax sin bx is nothing but x of b plus x square of ab plus b of 3a square minus b square x cube by 3 factorial up to x power n by n factorial of a square plus b square sin of n tan inverse b by a from this. Thank you.